Hello and welcome to my channel, Boo Snakes and More. For more videos like this, also watch my other house channel, A&A Snakes and Stuff, my youngest son's channel, Henny's Toys and Games, or my oldest son's channel, Little Chris 10. Today we're going to be talking about NASA and the solar eclipse. So please like this video and subscribe to the channel. Now let's dive in. Eclipses inspire awe and bring people together to observe a stunning celestial phenomenon. But these cosmic events also enable scientists to unravel mysteries of the solar system. During the total solar eclipse on April 8th, when the moon will temporarily obscure the sun's face from view for millions of people across Mexico, the United States, and Canada, multiple experiments will be underway to better understand some of the biggest unresolved questions about the golden orb. NASA will launch sounding rockets and VWP-57 high-altitude planes to conduct research on aspects of the Sun and Earth that's only possible during an eclipse. The effects are part of a long history of attempts to gather invaluable data and observations when the moon temporarily blocks the sun's light. Perhaps one of the most famous scientific milestones connected to an eclipse occurred on May 29, 1919, when a total solar eclipse provided evidence for Albert Einstein's theory of general relativity, when the scientist first systematically described in 1916 according to NASA. Einstein had suggested gravity as the result of the warping of time and space, distorting the very fabric of the universe. As an example, Einstein proposed that the gravitational influence of a large object like the sun could deflect light emitted by another object such as a star virtually behind it, causing the object to appear a bit further away from the perspective of Earth. A science expedition to observe stars from Brazil and West Africa, led by English astronomer Sir Arthur Eddington, during the 1919 eclipse, revealed that some stars indeed appeared to be in the wrong place, validating Einstein's theory. The finding is just one of many scientific lessons learned in relation to eclipses. During the 2017 eclipse across the U.S., NASA and other space agencies conducted observations using 11 different spacecraft and 2 high-altitude planes. Data collected during that eclipse helped scientists to accurately predict what the corona, or the sun's hot outer atmosphere, would look like during eclipses in 2019 and 2021. Despite its blazing temperatures, the corona is fainter in appearance than the sun's bright surface, but it appears like a halo around the sun during an eclipse, when the bulk of the sun's light is blocked by the moon, making it easier to study. Why the corona is millions of degrees hotter than the sun's actual surface is one of the enduring mysteries about our star. A 2021 study revealed some new clues showing that the corona maintains a constant temperature, despite the fact that the sun experiences an 11-year cycle of waning and increasing activity. The findings were possible thanks to more than a decade's worth of eclipse observations, according to NASA. While quieter during previous eclipses, the sun is reaching the peak of its activity called solar maximum this year, affording scientists with a rare opportunity. And during the eclipse on April 8th, civilian scientists and teams of researchers can make new discoveries that potentially advance our understanding about our corner of the universe. Sending rockets into an eclipse. Observing the sun during eclipses also helps scientists better understand how solar material flares from the sun. Charged particles known as plasma create space weather that interacts with an upper layer of Earth's atmosphere called the lunar sphere. The region acts as a boundary between Earth's lower atmosphere and space. Energetic solar activity released by the Sun during solar maximum could interfere with the International Space Station and the communication infrastructure. Many low Earth orbit satellites and radio waves operate in the lunosphere, which means dramatic space weather has an impact on GPS and long-distance radio communications. Experiments to study the lunosphere during the eclipse include high-altitude balloons and a citizen science endeavor that invites the participation of amateur radio operators. Operators in different locations will record the strength of their signals and how far they travel during the eclipse to see how changes in the lunosphere affect the signals. Researchers also conducted this experiment during the October 2023 annual eclipse, when the moon didn't completely block the sun's light, when the data is still being analyzed. In another repeat experiment, 3 surrounding rockets were lifted off in succession from NASA's Wallops Flight Facility in Virginia before, during, and after the eclipse to measure how the sudden disappearance of sunlight impacts Earth's upper atmosphere. Arona Bajader, professor of engineering physics at Embry-Riddle Aeronautical University in Daytona Beach, Florida, is leading the experiment, called the atmospheric participation around the eclipse path, which was first carried out during October's annual solar eclipse. Each rocket will eject 4 soda bottle-sized scientific instruments within the path of totality to measure changes in the lunosphere's temperature, particle density, and electric and magnetic fields about 55 to 310 miles above the ground. Understanding the lunosphere and developing models to help us predict disturbances is crucial to making sure our increasingly communication-dependent world operates smoothly, Vegeta said in a statement. The sounding rockets were reaching maximum altitude of 260 miles during flight. During the 2023 annual eclipse, instruments on the rockets measured sharp immediate changes in the lunosphere. We saw the participations capable of affecting radio communications in the second and third rockets, but not during the first rocket that was before peak local eclipse, Vegeta said. We are super excited to relaunch them during the total eclipse to see if the projections start at the same altitude and if their magnitude and scale remain the same. Soaring above the clouds, 3 different experiments will fly around aboard NASA's high-altitude research planes known as WB-57s. The WB-57 can carry almost 9,000 pounds of scientific instruments up to 60,000 to 65,000 feet above Earth's surface, making it the workhorse of the NASA Airborne Science Program, said Peter Leyshock, manager of NASA's WB-57 High-Altitude Research Program at Johnson Space Center in Houston. The benefits of using WB-57s is that the pilot and an equipment operator can fly above the clouds for about 6.5 hours without refueling within the eclipse's path of totality spanning Mexico and the U.S., allowing for a continuous and unobstructed view. The flight path of the planes mean that the instruments will be within the moon's shadow for longer than they would be on the ground. 4 minutes of totality on the ground equals closer to 6 minutes of totality in the plane, Leyshock said. One experiment will also focus on the lunosphere, using an instrument called a lunosnod, which acts like radar by sending out high-frequency radio signals and listening for the echoes as they bounce off the lunosphere to measure the number of charged particles it contains. The other 2 experiments will focus on the corona. One project will use cameras and spectrometers to uncover more details about the temperature and chemical composition of the corona, as well as capture data about large bursts of solar material from the sun known as coronal mass ejections. Another project led by Emil Caspi, the principal scientist at the Southwest Research Institute in Boulder, Colorado, has the goal of capturing images of the eclipse from 50,000 feet above Earth's surface in the hopes of spying structures and details within the middle and lower corona using high-speed and high-resolution cameras capable of taking images in visible light and infrared light. The experiment will also look for asteroids that orbit within the sun's glare. In the infrared, we don't really know what we're going to see, and that's part of the mystery of these rare obstructions, Caspi said. Every eclipse gives you a new opportunity to expand upon things. Will you take what you learned to the last eclipse? At the last eclipse, and you solve a new piece of the puzzle. Thank you for watching this video, and peace out to the next one.